We're going to be talking to you guys about domes. My name is Valeria Magallanes. I am a civil engineering student at the University of Nebraska at the Omaha campus.
And I'm Brandon Vogel. I'm a biological systems engineering major at the University of Nebraska-Lincoln campus. Domes are found all over in the world around us. How many of you guys have been on this before? It's a simple dome shape that can be found in many playgrounds across America. I know when I was a kid, I would always want to climb to the top, but sometimes it'd be kind of hard to get to the top because of the dome shape that all comes to a peak. It kind of steep on the sides and then eventually levels out at the top. Anyone know what this is? Well, this is the Desert Dome. It's seen at the Henry Doorly Zoo. And this dome is one of the most famous domes in all of Nebraska. And it is found in the zoo, and it's very cool to like go inside of it and just see it all come together to form a domal shape right here in Nebraska.
Okay, so today we're going to be talking about the history, science, and engineering that goes behind the creation of domes. So we're going to start out and talking a little bit about the history of domes. So domes aren't necessarily like a new concept. The idea of a dome goes back to like a couple hundred years ago, and it started out really small. So it started out with like huts made out of mud and branches and clay. And then it kind of converted into bigger structures. So the Romans kind of started what we consider to be a dome. They found out that the shape of an arch is really strong. And so they thought, what is a way that we can take advantage of how strong an arch is? And then thought of making it like a spherical shape or a semisphere. And that's kind of how domes came to be. So then as time went on, it started becoming prominent for domes to be in like the top part of structures. For example, the Taj Mahal, which is a mausoleum that was built for an emperor's wife. And it's this very famous structure. And as time has passed, we have developed even newer, different kinds of domes, even moving domes, like you can see in the picture on the far right.
There are many different types of domes. On the right, you can see the cloister vault dome, and this dome is a type of dome that kind of comes up on stilts and then all comes to the center to create a dome-like shape. And they can be found in like many different cathedrals and famous churches. The onion dome is kind of a dome that looks like an onion, if any of you guys have seen that. And this is kind of a dome that like comes up and then goes out a little bit and then comes back to a point. And these domes are found in many different architectures as seen here. And the geodesics dome is an example of the desert dome that I talked about earlier, where it is like a half-filled dome that kind of forms like a globe to the top, so it kind of looks like globe-ish and creates a domal shape. Today we will be learning about history, science, and engineering. Next, we're going to talk about the science that is behind the creation of domes. We will learn about three main physics concepts behind dome creation: forces and loads, tension and compression, and equilibrium.
All right, so I want you to start out and try and think if you know what a force is. So in order to understand like forces and loads, you have to understand what a force is. So force is an action of like pushing or pulling. So for example, if I were to kick a ball, I would be exerting a force onto the ball. My foot would be pushing onto the ball. Or for example, if you're pulling on a rope, the force that you're exerting on the rope is pull. So just try and think of it as the interaction that you have with an object, whether a push or pull. And a load is due to weight, so how heavy something is. So for example, you have the force of gravity, which is a force that pulls you down towards the earth. And this is important because in buildings, engineers have to take into consideration how heavy a building is. For example, if you have a building standing on still ground, it's not going to move because gravity pulls it downward. But if you have a building on a slanted territory, the gravity force is going to pull it down. So sometimes this can cause buildings to tilt over or fall. So forces and loads kind of work together in order to make sure that things stay up or they fall down.
All right, so next we're going to talk about forces that are working against one another is tension and compression. All right, so can everyone hold their hands up like this? All right, then put them together. Do you feel that force between your hands? Well, that is an example of a compression force when two forces are opposing each other and come together and exert force onto each other. All right, everyone put your hands like this, kind of make C's with them, put them together and then try to pull them apart. It's very difficult to pull apart, and that's an example of a tension force, when things are pulling apart one another. An example of this for a compression force is when you have a straw, when you push it together, it kind of bends. And when that bending, we don't want that when we're creating any sort of building and domes like this presentation. And so our goal is to minimize those forces when building domes. And then another example of tension forces is when you have a rubber band. The longer and longer you stretch that rubber band out, the more likely it is to snap, and we don't want that when building buildings as engineers.
So now we're going to talk about equilibrium. And equilibrium is when opposing forces are in like a state of rest or balance. So equilibrium is when forces cancel each other out and there's no more movement. So as Brandon mentioned, there's forces of compression that push against each other or forces of tension that pull against one another. So try and think if you guys have been on a seesaw before. You can use this as a perfect example of equilibrium. So in a seesaw, when there is weight on one side, it will move down towards the side that's heaviest. So if you're ever on a seesaw with a friend, the seesaw will pull down on either side. Now, an example of equilibrium is when there's two people and they exert the same amount of force on either side. So for example, if the people weigh the same, the seesaw would be in equilibrium, meaning that you could be sitting on the seesaw without there being any movement. And this is important because we want equilibrium in the buildings that we make. So for domes, since they're arches, there is a possibility for a lot of movement or for gravity force to try and pull our dome downward. And that's not what we want. So engineers have to think of a way in order to have equilibrium and have our forces cancel out so that there's no movement in our building and make sure that it's safe.
Today we have learned about the history and science, and next we're going to talk about the engineering behind the creation of domes.
So as I mentioned, engineers play a large role in dome creation. So first we have civil engineers. So civil engineers are the ones that oversee the how the structure is built. They make sure that the forces that we talk about aren't going to have a big impact or that they're in equilibrium and make sure that our structure is going to be stable. Next, we have mechanical engineers. So if you have a newer sort of dome, you are probably going to have some sort of movement or any moving elements. So mechanical engineers take care of any movement that there could be on our dome structure. Next, we have materials engineer. So material engineers actually play a really important part because they determine the different materials that our domes can be built of. If you think back to our history slides, the domes were first created with mud and clay and branches. So materials engineer look into different materials that our domes can be built of, for example, plastics, fabric, steel, concrete, and they kind of look into what's going to make our dome not so heavy, but also cool and safe. And then last, we have geotechnical engineers. So geotechnical engineers are a specialized part of civil engineering, and they work on the foundation. So they make sure that the soil or the ground that our dome structure is going to be on is stable, that there's not going to be any movement that could possibly cause our dome to move or slant, and make sure that it's able to stay in equilibrium and standing. So an example of how engineers have improved domes is the Metrodome. So in Minnesota, there was this big sports stadium, and it was actually a really cool stadium that people would visit. And there was this large standing structure. However, the fabric that was on top of the dome was standing due to pressure and forces that engineers had worked on. And in an instance where there was snow, the snow exerted too much force on a certain area of the dome, and it caused the entire dome to collapse. So this is one of the ways that engineers have had a large impact, not just on buildings, but on specific ones such as domes. They make sure that they're going to be safe for the people and that they're going to be innovative, cool structures that people can use.
Today we learned about the history, science, and engineering behind the creation of our domes. In conclusion, engineering is essential to our health, happiness, and safety. To create magnificent structures such as the Desert Dome and the largest dome in the world, which is in Singapore, and this is a retractable dome and just so shows one of the many modern innovations in the world today.
Thank you.
Thank you.